the flap will move. This will measure the pressure, the previous here, this side and that side. The difference of pressure will be calculated as a flow. So this is another method. Okay, these two methods are very old methods that we have been using this to measure the flow in the equipment. Okay, this is almost 30 to 40-year-old technology we have been using. Nowadays, we are using a different technology, that is ultrasonic method. Okay, so we have two ultrasonic sensors. When the patient is exhaling here, the first sensor will send the signal, ultrasound signal, and then it will hit at the end of the cassette, and then the second one will receive. Okay, this is transmitter, this is receiver. Then immediately the second one will act as a transmitter, and this will send the impulse, ultrasonic impulse, and then it will hit and then this will receive. The time difference is calculated as a flow. So this is the precise way of measuring the flow in modern ventilators. This is the same technology that we have been using in ultrasound when you are seeing all the organs. Okay, the same principle we are using, and this is the same principle we will be using in naval technology. When some things are fallen into the sea, okay, the Navy people, how they find out, I mean, where exactly it is, they will send the ultrasound impulse and they will measure how depth it is. Okay, then they will calculate how much time it will take to go and reach and then take that things. So the technology used in naval also, the same technology we are using here, and we are measuring the flow. So there are different ways of ventilating a patient. Okay, controlled mandatory ventilation, synchronized mandatory ventilation, and spontaneous mandatory ventilation. Okay, spontaneous mode of ventilation. Controlled mandatory ventilation is nothing but whatever the parameter that you are setting on a machine, it will be delivered to the patient exactly, and it will not allow the patient to take a breath. Okay, this kind of ventilation will be done when the patient is unconscious. Okay, so once the patient is gained conscious level, he will start breathing on his own. Then we need to change the mode to support mode of ventilation, that is called synchronous intermittent mandatory ventilation. This will allow the patient to breathe in between the mandatory breaths. Then if the patient is breathing good, then we will put them on spontaneous mode of ventilation. All the breaths will be taken by the patient, and we will reduce the support from the machine step by step. So these are all the steps that we have been using. So the technology improvements is, you have seen that, I mean, trigger. Okay, the trigger is, there are two types of trigger. One is pressure trigger and another one is a flow trigger. I think that whenever the patient wants to take a breath, he has to create a negative pressure, whatever the sensitivity level that you have set on a machine. Okay, if you set minus 2 centimeters, the patient has to create minus 2 centimeters of pressure. Then the machine will identify, okay, now the patient wants to take a breath. So it will allow the patient to take a breath. Okay, that is pressure trigger. The flow trigger is nothing but there will be a continuous flow in the circuits, in the patient circuits. If there is a reduction of flow, that will be identified by the machine, and then it will give the support to the patient. This is another technology that we have been using. But the latest technology what we are using is, we will be detecting the impulse from the brain. Okay, the normal process of ventilation is, the signal comes from the central nervous system, then it goes to the pharynx nerve, it goes to the diaphragm. Diaphragm is the biggest muscle, okay, in respiratory muscle, and then once the signal reaches to the diaphragm, what will happen? The diaphragm will contract, and then it will create the negative pressure inside the pleural space. This negative pressure is identified by the sensor in the machine, and then it will deliver the flow to the patient. So this is the usual way of ventilating the patient. What we are doing in NAVA is neurally adjusted ventilator assist. It is a new technology. We are inserting a catheter. This catheter will take the signals from the diaphragm. Once the neural signal reaches to the diaphragm, and then it will be fed to the machine. So we are bypassing this process. This process will take longer time. So this we are bypassing, and we are delivering the flow immediate when patient initiates the breath. So this reduces the asynchrony. We have discussed about synchronization. Synchronization is nothing but when the patient initiates the breath, immediately the machine should respond and then it should deliver the breath. So here we are avoiding the asynchronization. Because of that, we will be able to ventilate a patient easily and weaning will be done faster. So in future, how the ventilator should be? The future ventilator will provide a protocol-based approach to provide the mechanical ventilation. It is like a autopilot. No doctor should be there, no therapist should be there. If you put a patient on a ventilator, automatically the ventilator will take care of the patient and then you should wean off the patient. So the machine can decide everything. Okay, almost it is reaching that point. We have come to that point. We have auto mode, we have NAVA, all these are nearing to that point, protocol based ventilations. Future ventilator will be able to interpret waveforms and adjust the gas delivery based on the recognition of asynchrony. So we are discussing about the asynchrony that will reduce that ventilation part of it. And smart alarms with possible solutions and should be disease specific ventilation. There are a lot of disease. I mean, Loknath has discussed about the ventilator induced lung injuries, okay. So we can minimize if it is possible to find some modes disease specific ventilation for exactly the disease specific. Okay, before finishing my presentation, so I would like to share one thing. So when I was working in an intensive care unit, one of the multi-specialty hospital in Chennai, when I was a respiratory therapist and I was the head of the department. Okay, this has happened 10 years before, 15 years before, sorry. If you put a patient on a ventilator, okay, the chief doctor will come out and then they will say to the, all the relatives, you can tell your relatives, okay. So you can inform all other relatives, the patient will not survive. That is the scenario it was there 15 years back. Now it is not like that. So even if you put a patient on a ventilator, it is possible to survive and we can bring the patient out without any problem. Thank you.
Tomorrow the first program will be basic life support concepts which will be held in the Stimulation Center, SRM Hospital on the 4th floor. Participants, delegates and faculties are requested to assemble in the mini hall 1 at 8:15 sharp. Also, students should bring their own laptops so that the Mimic software can be installed in their own laptops. Lastly, I would like to thank our HOD, Mr. P. Angurajan, for arranging such an informative session for us. Secondly, I would extend gratitude to the delegates for their time and effort. Last but not the least, I would like to thank all the students and participants gathered here. Thank you very much. Also, we have arranged a demo for you. On the stage and off the stage, you're free to view all the instruments and get a hands-on experience. Thank you very much.
So the compressor is the unit which sucks the atmospheric air and then it will make pressurized and then it will be sent to the machine. And this air is filtered here because we need to give pure air to the patient whenever you are giving. Okay? And it is connected here. You see the module here. Here the air is connected. Here you have to connect the oxygen. Okay? So inside the machine it will mix both air and oxygen. And then whatever the percentage that you are setting to the patient, exactly to deliver the percentage, what are the percentage of oxygen that you are setting. So this is compressor, this is patient unit, whatever the blocks that I have shown, pneumatic block, control unit, inspirator channel, expirator channel, all this is inside this. Okay, this we will call it as a patient unit. And this is user interface. So what are the input that you want to give? You can type it here. I mean, you can,
this is actually a fiber optic technology. This is not a fiber optic. To measure the pressure, okay, you need to use a transducer for monitoring the pressure. But for this machine and for this catheter, you don't need a transducer. Okay. See, in this balloon, there is a manometer. The tip, you have a miniature manometer. That is the one which is going to reflect your pressure and show it in your digital sense. So when I insert it here, which will be in the heart, okay, that is the pressure which is showing it when you tie the cuff. Okay. So that pressure I showed it in the slide. So a light will be passed, okay, through this orange color cable. Okay. See, this is the pneumatic system. Okay.
The oxygenator, we pump it back to the patient again for longer duration. So cardiopulmonary bypass does it for shorter duration to keep the patient alive. But ECMO is nothing but extracorporeal membrane oxygenation. Don't get confused. Nothing but it is an artificial circulation which is happening outside the body. The natural circulation which is happening inside the body, it is natural. It is
Design is called as coaxial design. We have more space for the shuttling. So first, the negative force takes this bounce on.
how does it look like?
it is not possible to deliver the same quality to all the patients.
Which has a
If I am delivering 500 ml to me, I cannot deliver 500 ml to her. Okay. So the volume will vary, depends on their body surface.
So coming inside, pushing it. This coming inside is done by a negative force. And then it is being pushed forward. And then
You correct this down cord always. Okay, in order to do as a see this machine, the first thing you should know is
and they were able to come online video conferencing every month, and the experience replica was built in our hospital, right? Okay. So to put it in a nutshell, simulation, how we look at it was that, see, difficult situations, the intern doesn't have time to see. For example, an MBBS student or a physiotherapy student in ICU or a casualty doesn't have time to see all the different multitude of cases, right? And so, but if he passes out, he's expected to know how to treat or see these in the community or the hospital, whether it's government hospital or medical college, because we're supposed to work. In a simulation center, we can put all these different scenarios and then make the interns go through this field so that at least cognitively he knows how to work with it. Number two, well, for example, an act of intubation, innovative intubation, it's difficult to learn on a patient, right? And the thing, I have worked in ICU in Madras Medical College for almost 17 years and also in SRM for almost 7 years. So when a patient is crashing and I want to intubate the patient, there's not the time for me to teach another intern or student, right? So you already know the procedure, you've gone through the procedure through simulation. I am more confident of making him right rather than it's wrong. Do you understand? So the different cognitive simulation. You can hear me, all of you can hear me. Number three, you can make a mistake on a mannequin. Suppose during process intubation you may break this teeth perhaps, but it would be unwise to break the teeth of the patient, right? So the amount of mistakes made on a real patient scenario is lesser if you practice on mannequin. So nowadays simulation has become the order of the day, and throughout the world high stakes assessment has come in. Even for undergraduate training, simulation based certification is becoming mandatory. The Medical Council of India has now made it mandatory just now, and all the different medical colleges in India, AIMS Delhi started in 2009, and Manipal Medical College in 2009, and we started in 2011. Okay, so we just thought we'll give an exposure to all of you, because anyway, biomedical people, all of you, you are in the college, you are working in the hospital, right? spectators. So you should step in and at least do a CPR. That's why we are very proud to say that our HOD Biomedical is trying to take steps to make it mandatory for every student passing out of Biomedical College to have basic BLS skills. We have an American Adoption accredited BLS program and ACLS program too. Okay, so we're trying to get that inside, and not only courses wise, small scenarios which are going to be exposed to. For example, mechanical ventilation. Probably you know the electronic components behind the ventilation. What is the mixing chamber, you know, and all that stuff. And what is the compressor? What's the turbine? All that stuff. But then what is the patient aspect, patient interface aspect of it also? Don't you think you should know? Because having worked in ICU, I have faced this problem. Really. Because some problems say, go to inlet error, one thing will come, one alarm will come. Then I tried to troubleshoot myself as far as I can. Okay? Suppose I am not in spot, another junior doctor myself may call the biomedical engineer, and if he knows it's just a simple problem of some leak there, patient side, endotracheal tube is cup is very loose, and then he says he spots that out and says advises this is the problem, not something wrong with the machine. It's not the machine in problem, it's the patient in problem or the machine side problem. Also, I think we should be able to diagnose. And am I right? Am I right? That's the reason why we are all together, so that we can see the patient side problem also from interface from the biomedical equipment, which you want to bring into the curriculum in the biomedical college. Okay? So now with this brief introduction, nothing like doing. Okay? And when you do something, you learn better. Can I have 4 volunteers from different colleges? We're going to do two-minute program. Can you come? We can volunteer, raise your hand. I want 2